Hey everyone, thank you so much for joining. I hope you had a great week. This is Sidharth. I'm a community manager at Aviyel. Aviyel is on a mission to help open source projects sustain by creating communities around them. And we're also trying to build monetization avenues that help incentivize the contributors that help in the growth. Welcome to another session of the Contributor Roadmap series. Contributor Roadmaps is a step-by-step approach towards open source contributions. The roadmap for Doxy, TypeSense, and MobSF are now live. The link will be shared in the chat. In this session, Sidhant, who's a software engineer intern at Flexible, will be introducing us to the programming language Python. Sidhant, over to you.
Hi guys, thanks for tuning in. And just to clarify, I'm Sidhant with an N and he's Siddharth with an R. So I hope you guys are doing well. Like, can I see something in the chat? Like, are you familiar with the basic programming knowledge? Like any language, anything, any concepts? Any responses? Cool. So that's great. So when I go over Python and all, I'll be assuming some basic things that you'll know, like what a variable is or what if else is and so on. But if you have any doubts, you feel free to ask. There's a Q&A section here, and I'll periodically check and I'll answer all your questions to the best of my ability. So and also towards the end, I'll have another last like Q&A where you can ask anything related to Python, and I'll also give you my contact details so that later on, even after this session, if you have any problems, any doubts, anything, you can talk to me. So that should be it. Should we start, Siddharth? Okay, so start then. I'll share my screen. So can you see my screen, by the way? Cool. So for this tutorial, I'll be using VS Code. You guys can use any editor. Sublime Text, I've heard is good. Atom is also good. You can use anything. Oh, also, by the way, you should have Python installed before this. So you can just go to this link. I'll just paste it here. I'll also paste it in the chat. One sec. And from here, you can download the latest version of Python. A point of note here is that please download the Python version 3 point something, like above 3. Don't download something from 2 because 3 is just better. And the latest version is the best version. I'll be using, I'll show you. I'll be using Python 3.8.10. So I'll be posting this code on my GitHub. I'll put the link later. And if something doesn't work, please check the version. If you're on 2.7 or something, then some things might break. So once you've installed Python, you can, like in the command line, you can use this command to check if it is installed properly. So Python -- version it should show the version that you have. And in some cases, if you're using Python 3, you might also need to use this add 3 in the end. So Python 3 -- version. In my case, I have set it up so that like it both works, but in your case, one might work and the other might not. So that's how it is. Okay, so let's actually start with Python. So the first thing that I should probably go over is commenting. So if you're going to work on open source projects, which is the point of this, comments are extremely important. This is how you add content to your code that you want to tell other people, like other developers, for future reference, but you want the Python interpreter to ignore it. So you do that with the hash symbol. So if I add a hash and I can type anything here, and this will just be ignored by the Python interpreter. So you can add anything here. It's usually used to describe something. So if I declare a variable, like a variable is something S or something, like 5, 4, whatever, and I can describe it. This is something. So in the future, some developer that is trying to build on top of what you built, they will look at this and they'll understand instantly what's going on. So this is extremely important if you're going to work with open source or if you're going to do internships or anything. Now this is a single line comment. What if you want to do multi-line comments? You can do something like this, of course. Second line, third line, and so on. There is another way. Three codes, VS Code, three codes, single line codes, single codes is, or you can also use 3 double quotes. Both of these, that's 4. Both of these you can use for multi-line comments. So you can put anything in between this. This is comment. Hello. You can put anything, multi-line comments, and this will be ignored completely by Python. So that's the basics, right? Now let's go over something. How do you declare variables in Python? So if you're familiar with other languages, you might be familiar with, like, int a equal to 5 or something like that. In Python, you don't need to do all this. Python is a very smart language. So if you just do, say, a equal to 5, Python will automatically understand. It will infer, okay, a is a variable, a is an integer. So that way you can actually do anything. Here you can add a variable. So Python will automatically understand that b is in fact a string. Say you can also have float. You can also have like an entire, like, something dictionary. E1 value. You can have literally anything. Python is smart enough to resolve it. What's more, you can also do something like this. A is equal to 5, and then on the next line, you can do something like this, and this thing will be pointed to a string. So it's pretty cool that way. Another thing that you should probably know is, once you suppose you do a equal to 5, but you want this 5 to be a string later on. Like, you want to convert this 5 into a string. So how do you do that? In Python, you can use typecasting to change the type of the variable to something else. So suppose this is 5, this is an integer. So let's actually print this out and check. Oh, by the way, I should probably have mentioned this in the beginning. To run a Python code, you simply do Python and then the file name, right? And the file name ends with .py. So it's as simple as that. There is nothing fancy here. So once we run this, we see that Python has inferred that a is actually an int, right? But the problem is, suppose we don't want it to be an int. We want it to be a string. So you can simply convert it. Suppose b equal to str of 5. So what this does, str just stands for string. What this does is it converts 5 to string. So now if we check the type of b, say string, right? To show you the difference properly, let's print the type a also. See? So with this, we can change the type of anything to something else. So in this case, we have string. We can do, like, if 5 is something else, we can do int. We can do float. Look, anything you want, right? So up until now, do you guys have any questions, or is it fine? Checking the Q&A section. So when I'm talking, you can put in the questions, and later on I can keep checking what is going on and I can come and see. Okay, so I don't see any questions. It's pretty cool. Cool. So next, let's look at what we can actually do with these variables. So let's comment this out. Oh, by the way, this is just a VS Code trick that I'm doing. If you like select a bunch of things and use control CTRL plus slash, this is a shortcut for commenting the entire thing. So if I just select this, I can comment and uncomment this. So this is just a efficiency trick that you guys can use. It's not Python. So now we have our variables a equal to 5. Now we want to do something with this 5. I feel like there is no point, right? So let's take another variable 10. In Python, you can simply do all the basic math operations as simple as you would type it in English. It's just like any other programming language. So if you can do a plus b, or you can do a minus b, or a divided by b, and so on. So it's as simple as that. And a point of interest here is that when you divide a by b, 5 by 10, Python inferred that c is a float. That's interesting here, right? This is not an int. Python inferred. It understood that, okay, we need a float here to check this out. But what if you don't want it to be a float? Like during production, you don't want floats and ints to like interchange and screw things over. So that there, as I said before, you can use the type conversion, convert it back to an int. So it's 0.5 and now it became 0. So it's as easy as that. And other than that, you can also do conditionals. Now, before conditionals, I want to talk about if else. So in the beginning, I actually assumed that I asked if you're familiar with if else. So I think most of you are, but if not, I'll just briefly go over it. It's basically something like this. We have an if block, then we have a condition, then we do something, or else we have another condition, do something else. So it's used to evaluate conditions. So if there is one condition, it's true, we do something. And if we do something, if that condition is false, then we do something else. It's as easy as that, right? So in Python, you can do this very easily. If A is greater than B, suppose, and we add a colon here. This colon is important. And we evaluate, like say, print A, else print. Okay, so now here we hit upon another peculiarity of Python. So this is actually kind of important. So pay attention, right? If you're coming from other languages, you might be familiar with the parenthesis. You might be doing something like this. If something, then parenthesis, like here. And then if else, you do another parenthesis, right? Python handles things a bit differently. What it does here is that it uses these indents. Indents are basically this space that we use to separate these print statements. It uses that to evaluate what is inside that block. So it goes without saying that these intents are it's extremely important. It is important to get right. So for example, if I just bring it back here, this will throw an error. As you can see, like with these red lines, it will throw an error because now there is nothing inside this if block. Python doesn't know that this print statement is inside this. It can only understand that if it is two spaces to the here. Suppose we remove one space. If we just put one space, even then this indentation is not valid. Here is not showing that, but it actually is. I have run into many situations where a tab and two spaces, both of them were interchangeably used inside the code. and it just broke, and I couldn't understand what was going on. So make sure to get the indentations right here. So here, as I said before, we have if a equal to a greater than b, we have a condition, then we just print a. Else, like if this condition is false, then we go to this print statement. So let's run it and see what happens. It prints b. So here b is 10, a is 5, so it worked, right? Now we can also do other conditions like let's do other conditions equal to. So if you do, if you're not familiar with this, a single equal to is used for assignment. So if you do b equal to 10, then the value of b is said to be 10. But if you do b double equal to 10, it's like a check. Is b equal to 10? Like whatever is inside b, is it equal to 10? Right? So this difference is also kind of important. So here also, if you want to check if the value inside a and the value inside b, are they both the same? We'll just use double equal to. And if we do this, it will still print b because it will go inside the else box. A is not equal to b, as you can see from here. I'll go to b. Now we can also do not equal to. We can do less than. We can do less than equal to. We can do this. So there's a lot of options here. You can check for any condition that you want. So this is all for if else. Now I want to talk about some extensive these conditions itself, but in a bit more detail. So before that, let me go over some data structures. In Python, you can store data in many ways. So one way is simply straightforward: a equal to 5, b equal to 10, just like you saw. But then what if you want to store multiple things inside a single variable? So for example, you have fruits, say. Now you can't do apple, orange, grapes or whatever. I mean, you can do this, but it doesn't fulfill the purpose. What you actually want to do is this should be one thing, and this should be another thing, this should be another thing. But here, this entire thing is just one string. So how do you accomplish this? We want all these elements to be separate. So in Python, there is a thing called list. A list is basically it's self-explanatory. It's a list, but more importantly, it's like an array. If you're not familiar with computer science fundamentals, I'll just go over array very briefly. An array is basically just a structure which contains many child elements. So we have something like this: orange and grapes. These three elements live inside this entire array, this entire structure. And the thing about array, it's why it's so important and so amazing, is that all these inside the memory, these three elements are stored continuously. So that means that suppose if you know apple, where apple is, inside the memory, it will have some address. You know where is apple. Now, suppose you want grapes. You can just do the position of apple plus 2. With that, you can get grapes. With other data structures, there is, I don't know if you're familiar with it, but there are some other things called linked list and so on. You'll have to probably go here, and then you have to go to the next one, then you have to go to the next one, and so on. It's a very tedious process. But with an array, since everything is continuous, you can just get the first. If you know where the first one is, then you can get the position of get the value of any of the elements in the array. And that is what we are going to be doing here. So how do we first declare an array. It is exactly like we saw here. We have something like this, fruits. So this is actually a list. And now we can get the value at any position using this number 0, 1, or 2. Now, in any programming language that you have ever used or will ever use, probably, it will always have a zero-based indexing. That's just a computer science thing. So Apple is at the 0th position, not the first position. It's at the 0th position. This is at the first position and this is at the second position. So if you want to get orange, say, so let's print it out. Orange is at 1, 0, 1. Oops. Yeah. We get orange. And this is super fast. Here you might not be able to tell because I mean everything is just fast, but if you can extend this maybe like a million or a trillion or whatever, then you will actually see how fast this is because of how this works. But then a very common question arises here. What actually is the difference between a list and an array, right? You might have heard of arrays in other languages, but then if this list performs the same actions, it works the same way as an array, then what exactly is the difference between them? So the biggest difference is Python's list is extremely flexible. In an array, every element has to be the same thing. Like, so this is a string, apple, this is a string. So this also necessarily has to be a string. This also has to be a string. That is what happens in an array. But in a list, this can be anything. This can be a number. This can be a float. This can be a dictionary. Like, it can be anything. This list can hold any type of items. So that is why Python lists are very flexible, and you should, consider using them more often. So yeah, so we have lists. Now we can combine if else and lists to check if suppose there is a thing inside the. So let's just add grades. Let's check if suppose like we want to find is apple present inside this list. How do we do that? In Python, we can simply, there is a very easy way to do this. We can just check if apple in fruits. Oh, oops. Yeah. Yes, there is. And if it is not present, we can print no. Oh, also, you might have noticed here that here I'm using a single quote and here I'm using a double quote. So in Python, you can use any, both means the string. It is interchangeable. It doesn't matter. You can use whatever you want. I personally prefer the single quote. You can do whatever you want. So it's pretty cool that way. Python is very easy to learn. This is exactly why. If we run this, we get, yes, there is. But what if we add something else like a strawberry? So now from this, you can kind of infer something that Python is almost like English, right? It is very basic. We have keywords like in. We can also use not in, which is the opposite. So if strawberry is not inside the fruit, we'll go to this place. So like that way we can very quickly find if an element is present inside the list or not. Next, let's look at operators. So here we had this, right? So let me just copy paste this very quickly. So here we simply, let me just see, yeah, it will be declared it. So if we run this right now, we print P. Okay, so Here we only check one condition. Here, this one, if A is greater than or equal to B. But what if we want to check multiple conditions? Like it is not very usual ki we just have one condition and we'll just get it. But there'll be many occasions where you will be dealing with many complicated conditional statements where this has to be true, this also has to be true, this also has to be true, and so on and so forth. So how do we handle this? One way, which is kind of very straightforward, is we just put many ifs inside it. So inside this if, we do if apples in fruits, and then inside this if we add another if b is less than a, and so on and so forth. We can do this, but as you can see, it's kind of cumbersome, right? This will get very tedious as it goes, like as it keeps going. So another way to do this is Python offers us another functionality called AND. This is an operator. So say apples in fruits. Here I am, and in this case, let me just put this here so that we can see. In this case, it will check A is less than or equal to B, and if apples are is present inside fruits. And you can keep chaining like this, and something something, and something something, and so on and so forth. So this is a much cleaner way of doing this, and it will go here. And since this is the AND operator, it means that this and this both have to be true. Only then it will go inside this place. So suppose if we go for OR, either this or this has to be true. So we have the AND operator, and both sides have to be true. And we have the OR operator, either side have to be true. Right? We also have another operator called NOT, which is basically just flips the it should not be true. So if we currently run this, suppose we have this, it goes to here I am. But then suppose if I do NOT, which basically flips this, if A is here we put A less than or equal to B, and when we add NOT, it basically evaluates to if let me just put here, sorry, if A is greater than B. That is what this evaluates to. This thing is flipped. If A is greater than B, and then it will go here, which in this case is not true. And when we print this as expected, it will go to this place. So yeah, I think I covered a lot of things right now. I should probably check if there are any questions. Can we use both exit control loops and exit control loops in Python? Both exit control loops and exit control loops. Okay. Okay. I will get to loops in a second, but if you're just here to get the answer, we can use entry controlled, but exit controlled, kind of, you can emulate it, but not exactly. I'll get to it. Okay, so until now, we have gone over, just a quick recap, we have gone over how to set variables. Variables have types, so integer, float, so on. We can check for conditions, if a certain condition is true or false or whatever it is, greater than, equal to, if it is inside a list, anything, we can execute certain code. Then there is a thing called list, which is kind of like an array, but it is like a continuous list of items which you can access using this, like you access using the index. Index starts with 0. I should probably type this down. Index 0. And finally, we have operators called AND, OR, and NOT. Okay, so now let's go over something that you guys will probably work on a lot. It's just strings. So until now, you might you know that string is just basically something like this Aviyel, let's say. So this is a string. String is just a bunch of characters that are enclosed with a double quotes or a single quotes. In Python, you can do this too. This is also valid. Okay, same thing. Now with this string, you can do many operations. So let's say is great. Now, if we see in case of normal numbers, we can do a plus b, a minus b, and so on. But what happens with this? Let's test it out. Yeah, you see. So in Python, we can use operator like plus to concatenate this, right? Now, to concatenate, you also have other functions, but honestly, like, why would you use that? Like, this is so straightforward, right? Now, you can also do something like this. You can format it pretty cool. The formatted string is a plus b, right? We have this, and then we have a comma because that is how print statements are, and then we have this. Or we can do this also, plus a plus b. It will give you the same exact thing. So this string is concatenated with a, then it is concatenated with b. Now, when you're dealing with long strings, there is also another way to do this, which is much cleaner, and I personally prefer it. And you'll probably find this is more common, and it is called f strings. I'll show you f strings. How you do this is, before the string, you add a single letter f, and this, we add this. Okay. What happens here is that when we add this f, it tells Python that this string is to be formatted. How is it to be formatted? Whenever we reach this bracket, like there's a parenthesis, curly braces, whatever you want to call it, whenever it hits this parenthesis, it evaluates whatever is inside this. So here, when we have a, it puts this a's value right here. When we have b, it puts b's value right here. So if we run this, we get the same thing. Of course, yeah, I missed this, and now we'll get the exact same thing. Okay, there's a space here, whatever. But this is a much cleaner way of doing things. So if you're going to work on projects and so on, be sure to use something like this. Also, something to note here: this f string, I think it only works for Python 3.6 plus, right? I'll have to check this for a sec. I think I have to check this, but this, as far as I know, I'm pretty sure that it only works for Python 3.6 and above. Since I'm using Python 3.8, as I showed you, it should work. And if you're downloading Python today from the link that I posted here, like, oh, sorry, I deleted it. I posted in the chat. You will probably get Python 3.10, which is higher, and it should work fine. So this is a point, this is a caveat. You should remember this. So some open source projects are still using old Python versions. So this might not work. So don't freak out. Just use this. This will probably work. And of course, you have other like functions in Python, which Python provides by itself. You have len, which just tells you the length. It's self-explanatory. 6. It counts the number of characters here. We can also also check if a starts with a, suppose. If we do that, it says true because it does start with a, Aviyel. Oh, also, let's check if what happens if this we do this. So that tells us that this A and this A, capital and small, it matters. It's case sensitive. So, and just like that, these variables also it matters. So if I just do, sorry, this capital A here, it will not work because this A is not defined. All things in Python is case sensitive. So remember that. Then we have another great function that you'll probably use a lot is split. This is used to split split a string into an array, so into a list actually. So this list that I talked about, what if you have a sorry, let's say we have a sentence. This is a great sentence. Suppose we want an array in the form of this. Well, you get it right. Anyway, so you want an array in the form of this. Sometimes you need it, like you have a long string, you want to break it into small parts. So this split method, it does exactly that. So let's see it work then. I'll just show it to you. As you can see, you get a perfect list directly from this sentence. This is send, and then we do send.split, and we get it. So there are many other functions like this. Starts with split, ends with we have find, which is used to find a character. You can go over through all of this. There are like hundreds. Python is very cool like that. You should probably know the art of Googling also if you want to be a bad developer. But anyway, let's move on now. Yeah. So what next? Yeah. So now I'm going to go over another data structure. So until now we looked at list, right? This is the list. There is another data structure called a tuple. The difference between a list and a tuple is that a tuple cannot be changed once you declare it. So I'll just show you very quickly. Tup equal to. The difference is another how you declare it is instead of the box brackets, use a parenthesis, and that's it. So apple, orange, is a tuple, and it works the same way. You can access it the same way. If we do this, we should get orange. It works the same way. The difference is, suppose we do something like this, equal to like berry. It doesn't work because you cannot assign it. But if it were a list, you could do it with no problems. It works. It's a berry. So that's a tuple. And finally, one more is a set. Set is the it's kind of like you can probably guess how we can do it. Wait 1 second. This I should probably change. Since I'll be uploading this on GitHub, I'll probably should yeah. So yeah, a set, since you can probably guess like how we declare it. In a list we use a box bracket, a tup we use a parenthesis. So in a set we use the curly braces. Now how a set works is that it's basically just like a list. You can it's basically just like a list, but the thing is that only no duplicate values can be stored inside here. So in a list, suppose we have apple, orange, grape, and then we can add another apple and another orange and so on. But here you can't do that. Here it's a single, everything has to be single, right? And the thing about sets is that you can I think you can use it to check if a certain thing is inside present inside the. I should probably change this st. So you can check if Apple is there, and you're guaranteed that there are no duplicates. So if I say if Apple is not there, it means that there is no Apple there. So just to a quick recap, a list is kind of like an array. You can have any type. We can have 1 or 2.0 and so on. You can have duplicate values also, and you can access them using this index. A tuple is just like a list, except you use a parenthesis to declare it, and once you declare it, you can't change it. That's it. In a set, no duplicate values are allowed, so it's usually used in this context. But honestly, you don't really use tuple and set a lot, but it's still good to know. It's good options. So I have done these data structures. Do you have any other questions? Let me just check. Okay, so we don't have any questions. Okay, so let's move on then. And now, okay, yeah. So let's go over the best data structure that exists, a dictionary. So this data structure, as you go on, you'll find that this is one of the best data structures that you can find out there. It will very quickly become your favorite data structure. And it's actually a joke that in coding interviews, if you cannot solve a question, just throw a hash map or a dictionary at it, and you'll probably be able to solve it. So let's go over quickly what it basically is. A dictionary is a data structure that uses a key value pair. Key value. So essentially, if we have a key like an ID, then it will also have a value 21. Then we can have other keys also. Name. We can have something like Aviyel. So it's basically just a key value pair. There's a key that points to a value. How do we declare it? With the curly braces. Then we just put in the key and the value. Then we put the key and the value. This is how you declare a dictionary. Now this is amazing because how you access these values is like this. Now from this itself, you might be able to see the power that is inside this data structure. You can, like here in all the above data structures that we talked about, list, tuple, and set, we always access it using a index. I don't think you can do that with set, but whatever. You can use it with index. But here, this you can actually put in a key that is a string, right? So you probably will you probably can see that this has a great potential when it comes to handling very complex complex problems where you need to store a lot of data and you need to reference it with something that is very easy to remember, like ID, very easy to remember, name or whatever, and you can keep adding keys here with no problems, like key 1, key 2, whatever. And even if you do that, even though if you look at the list, the index kind of it did change, but since we are using a dictionary and we are using this ID as the index, this doesn't matter. We can keep adding whatever we want and functionality will not break. So that is there. And then there are other technical things like this is very fast, this is constant time and so on. But I'll not go over all of these things because this is a bit more into like hardcore computer science. So yeah, so this is we have a dictionary. So I think any questions until now? Okay, no questions. Cool. So with the dictionary, we have many like functions, just like we saw in the just like we saw in strings. We can get the len. We can get the length, which is 2. We have ID and name. We can clear the list. Obj dot clear. I should put it here. So what this does is it just deletes everything. So you have a clean hash map again. So if we check a len here, should say 0. There is nothing inside the hash map. So we have many other functions like this. Python is just insane with the functions and the flexibility that it has. So in fact, you will realize the true power of Python later on when I go over modules. So another thing is that we can also like have a list inside an object. So we have list, and then we put in an object. So we have, let's just copy this. Right. So we have we kind of have a database almost. We have an ID, name, and list, right? So it's pretty cool. Now what do we have to go over? Yeah. So let's go over loops. I am probably getting close to answering Zed's question. So for those of you who don't know what a loop is basically just a block of code that is executed again and again until a certain condition is met. It's as easy as that. So we have something like, okay, so we have a equal to 1 and we have s equal to 0, right? Now we want to keep adding a to s over and over again. So s equal to s plus 1, and we want to do this 1,000 times. Now one option is you can just keep, you can duplicate it like this, so on, so on, so on, and it's fine, I guess. But when it goes to 1,000 times, it will get really bad and it's a headache, and honestly it's a nightmare I wouldn't wish on anybody else. So how do we do this? This is where loops come in. In Python, we get a very convenient way of running loops. We have the standard for loop. If you're familiar with any other language, this will also be very familiar. For I in range, so range is a function that returns all the values that we specify. Range, say 1,000, suppose. So in this case, this whatever is inside here, so blah blah whatever is here in this section, it will be executed 1,000 times, right? So you might be asking, what is this I then? This I takes up the value of each iteration. So when it goes through the first iteration, then I is actually 0. Then it goes to the second iteration, then I is 1. So it starts from 0 and goes 1, 2, 3, and so on until 999. Remember, I does not go to 1,000, because since it starts from 0 and it has to go 1,000 times, 999 is the last position that will take. So let's just see it in action. So what I'm doing here is this loop, it will run 10 times, as easy as that, and it will just print I. So let's see what actually happens. Let's see what I is. So as I said, I starts from 0, then it goes 1, 2, 3, 4, and it goes till 9. It doesn't take the value of 10, it takes the one less value. Okay. So this is one way of writing a loop. Another way of writing a loop, suppose we don't want I to start from 0, right? We want I to go from 5 to 10. So then we can just add another parameter like this. It starts from 5 and it will still not go till 10. It will go till 9. Let's see it in action. So we have 5 iterations, 5, 6, 7, 8, 9. And since it is starting from 5, it will not take the value of 10. It will just go till 9 and it will stop. So with this, let's accomplish what we went out to do. We wanted to keep adding a to s. So s equal to s plus a. This will basically just keep adding a to this value 5 times. So in the end, s should take the value of 1 plus 1 plus 1 so on till for 5 times, because this loop will run for 5 times and should give us the value 5. And as we can see, it gives us the value 5. So with the for loop, any questions? I actually went over the loop itself. So is it fine? Okay, so let's actually go over now the second type of loop that we have, which is the while loop. I should just comment. Yeah. Now, a while loop is something kind of different from the for loop. For loop has a variable called I. It iterates over the values, and with the while loop, we have a condition. Suppose A is less than B or whatever, and then it will keep running, right? It is the same exact thing. It will keep running until A is until this condition is false. If it is true, it will just keep running forever. So while loops have that problem. It can go on forever. You have to be very careful while using this. But if you do it properly, this is a great year. And now we come to the question that Zed asked about entry controlled and exit controlled. So entry controlled loops are basically just loops that are controlled by, like, in the beginning itself. Like when it enters the loop, it checks the condition, and it only enters the loop if it is true, right? So suppose if A is less than B, if this is not false, then it will never enter the loop. But exit control loops is something that will check the condition in the end of the loop. So if you're familiar with other programming languages, there will be a thing called do while loop. So what happens here is just enters this loop like randomly, and then after everything is done here, it will check the condition here file. But in Python, we don't have a do while loop. So I hope that answers your question. We only have a for loop and we have a while loop. We have blah blah. No, actually I shouldn't do that. S plus n. So we have something like this. This is an infinite loop. This will keep going because it is true. Okay, so we have loops, variables, everything we have done. And now I think we can go over to classes, functions and classes. So in Python, suppose you're designing a game, right? And when a player dies, you are a player and you die. You want certain things to be done. So what is it? So player dies. So we want something like this. So we show the end screen. We we make the health 0 and so on. Like you have a bunch of things happening like this. Suppose you're the creator of PUBG or something, and you have like thousands and I don't know, maybe a lakh players or whatever, and you want to do this. It's very cumbersome to write this code for each and every player, right? So in that case, what if we had a method to reuse code? We write the code one time and then we reuse it again and again. That is where functions come in. So we define a function called def. We have you'll probably I'll explain it better with an example. We have a func. Happening. We have, let's just print inside function. This is how a function is defined. This fun can be anything. This is just the name of the fun. We can make it gun, whatever. But this def is how you define a function. So that is what it means. And as usual, remember the indentation is very important here. Whatever this part is very important, and we use a colon to open the function. And then we can call the function like this. Just like this, we call it the wrong. Yeah. So it just goes inside the function. This way, you can also pass things to the function. So if you want to say, so let's say sum of two numbers, which is a very simple function. It just gives you the sum of two numbers. So we have, we define the parameters that we need two numbers, A and B, and we just return A plus B. So if any place here, it calls this function, it will take two numbers and return the addition of the both numbers. So let's just write out very quickly. Int sum of two numbers, and we have 5, 6, and we have 11. So it's as easy as that. Functions are quite easy. Any questions until now? Okay, so we don't have any questions. Okay, so now we will go over classes. So a class is actually, okay, I should probably, again, let's go with an example. We have a player, right? We are designing a game and we have a player. So let's say a player has some properties. Let's create a dictionary. We have a username, cool, or something, and we have a health, and 12 health. So we have player 1, which is a guy who has the username cool and health is 12. Now suppose you have another player joins, you can just copy paste this, and you can do this more and more times, and you can keep going for a million players. Again, this is the worst possible way to do this. It is a nightmare, and it's really hard to debug. And of course, if you want to change something, it's just a bad idea. So here, just like just like the function of, just like the purpose of functions, we can use something called a class to reuse what we have already defined. So let's just define a class first, and then I'll how do I do? Yeah. And then inside the class, we have certain things like what name, yeah, cool, and we can have a health equal to 21, and this is how the class ends. And now whenever we need a player, we can just do player 1 equal to player like this, and player 2 equal to player. This way, it is, as you can see, we defined the kind of like the blueprint of a player here inside the class, and then whenever we need more and more players, we just keep adding, we just invoke it using this thing. So it's kind of like a function, but you should remember this is how we do it. Oh, also convention is that a class always starts with a capital letter and a function starts with small letter. So we can now access player2.name. It. Oh, so we have access, cool. But the problem here is that whenever we do this player thing, we get the name cool. It is default. Everybody gets the name cool, right? Now we can actually change this if you want. Player2 dot name equal to something like, cool with a K. It will work, but this is also very prone to errors. If you forget to do this, many players will have the same name and the same health, and if you have something sensitive like an ID or something or password, it'll just go haywire. So what do we do here? One way, like the way that we used to do this, is something called init. So this is actually a constructor. So let me just write this down very quickly, and then I can explain to you. Okay, let's just print inside init. Okay, so this might look a bit intimidating, but let me explain it very quickly. So whenever we call this player, this thing, Python has a function called def init, like this, a double underscore init, then double underscore. So this is actually a function that is always called as soon as this is called. So when you do player like parenthesis, what's called an object is created, and an object is this player one. So whenever you do this player 2, another object is created. So both of these are actually objects. And whenever we create an object, we this function is called. Now let's actually test this out very quickly. So as you can see inside init, I didn't do anything. I didn't call it from anywhere. It just got, I just created this object and this was printed. Now, another thing that you might notice is this thing called self. So in Python, what happens is every function inside here. So let's say we have something called test2, test2. We have a function like this. Python automatically passes self to that also. All the function here has self passed there. So self, what it does is it allows us to reference all the methods, like the functions inside this class, and also these things. So if I just say, suppose print name here, now, you might think that, okay, name is here, it's quite straightforward. If we print name, this should get printed, right? But it will not, because this name, as far as Python is concerned, it doesn't know what it is. Where did that come from? So this self is used to reference that. So if I do self dot name, it means, oh, okay, self is like player, so it's current player, and then I'll take the name from it. And if we just do that, we get the name of the player. So coming back to this problem, what do we do about this default cool thing, right? So here in this constructor, we can also pass parameters. Just like we did here in the sum of two numbers like this, we can pass parameters here also. So let's say we pass something, name and health, we pass it. Actually, let's name it something else to avoid confusion. Temp name and temp health. And we do self.name equal to temp name, self.health equal to temp health. If you do this, it's quite straightforward. You can guess what is going to happen. As soon as this is called, an object is created, player 1. It goes inside this function init, because that's the constructor. It is always called as soon as it is created. We pass these things. We haven't passed it here. So let's just pass it very quickly. Cool and 21. And let's pass something here also. 100. So these two things we have passed, it goes directly to here. So temp name becomes cool, temp health becomes 21. And then we assign it. Self.name, which is this, is cool. Self.health, which is this, it becomes 21. So now we can safely delete this, because we are just assigning it here, right? So now if we run this, folks, we didn't print it, right? So if we print both the players' names, you'll see that one is cool and one is cool with the K. So it's working. So compared to the alternative that I talked before of just thousands of dictionaries that, player 1, player 2, player 3, whatever, blah, blah, blah. This is just a lot cleaner, right? You can see that. You can appreciate that. So that's all about classes. Another very minor thing, it's kind of obvious. We can add other functions here also, like print score, say, and then we can just print score. Sorry, health. Should be health. Oh, oops! I made that exact mistake that I talked about. It should be self.health, and here also self is passed. So as I said before, self is always passed to every function, and we reference health using self. Reference all the parameters that we are setting using self. So now if we do player 2 dot print health, just get the health of player 2. So we can call any function, and we just define this one time, and then we can keep using it as many times as we want. Player 1000, whatever. So it's pretty cool. So that this is kind of complicated. So are there any questions as of now? Okay, so Okay, cool. We don't have any questions. It's pretty cool. This is kind of confusing. I get that, but sure. If you guys have any questions later on, also, you can definitely ask me. Okay, so after this, just one final thing that I wanted to go over today is modules. So Python, if you ask me, give me one single thing that makes Python such an awesome language, right? Such a powerful language. Let's actually just make a new. Yeah. What makes it such a powerful language? So it is modules. Python actually has a lot of external modules that you can import into your own code. What is a module? It's just code that other people have written, other extremely intelligent people have written for your benefit, and you can just import it into your code and use it as if it's your own. So that way, it gives you tons of flexibility. So you let me just give you an example. There is a module called datetime. Now, datetime actually, if you have ever worked with it, uh, it's kind of a headache because you have to deal with all the different formats. You have to deal with time zones. You have to deal with a lot of things. But this module, some people have maintained this module, and they do all the heavy work for us. And for us, we only need to call it. So, for example, uh, we can just do datetime dot date dot like today, suppose int today. Oh, sorry, z dot by. So we just get the date today. It's 14th March 2022. So you have other modules also. Import requests. Now request is something that you use for to talk to the internet. I'll just very quickly show you. This is an amazing module that you'll probably work with the most because like come on, if talking to the internet is so exciting, it just gives you a world of possibilities. If we just do google.com and if we just print press dot content, oops, we'll have to add this also. This is the entire HTML. It looks horrible, but this is the entire HTML for google.com. As you can see, like you can maybe check out these things, href and class and so on. So you can probably tell that these are the things. So this is one module. So because of this, Python is extremely flexible when it comes to what you can do, like the capabilities of Python. So like for requests, you're using for connecting to the internet, datetime using for date. For AI, you use something called TensorFlow. Here it will not work because I haven't installed it. Then you can use, there is a YouTube channel called 3 Blue 1 Brown who who edits and who creates their entire videos only using Python, called with a module called Manim. So you can check that out. So there are tons and tons of other modules for every purpose. There is a module called Matplotlib. No, math. I think it's math. It's not T here. Yeah. So you can use this to draw graphs with data and so on. There's a module I think called CSV, which you can use to read and write to CSV files. I actually use this module to create a result scraper, which actually logs into my college and then college's results page, and it scrapes my results and so on. So you can create a lot of things with Python with requests, just with requests and CSV. So you have so many opportunities that you have. So I think that's it. Should I like? I think it's still it's 11:10, so I think I should stop here. So I hope you guys understood everything. If there are any questions, you can ask me. I'll also put my email in the chat box so that you can email me anytime you have questions. And you can also find me on LinkedIn, Instagram. wherever you want. Just message me. I'll help you out. Or even honestly, you don't even need a doubt. Just if you want to hang out, just message me. So that's it. Any questions? If you have, go for it. Otherwise, you can stop here.
Looks like there are no questions as of now, but yeah, please feel free to reach out to Siddhant and he'll be happy to answer all of your questions. His contact details are in the chat. But thank you so much, Siddhant, for doing this. And I'm sure the audience picked up a lot of important points from this. Thank you so much for joining us today.
Thanks. It's great.
And of course, thank you to the audience for joining us today. It's been great to have you here. And we hope to see you on the next session. We are having a lot more sessions planned for the contributor roadmap. So do check out the roadmaps and join us for the next section. We'll see you on the next one. Thank you. Goodbye.